Welcome back to the Casper Association certification course. It's time for us to put all the pieces together and deploy our very own contract onto the Casper blockchain. This is the final module of our introductory developer course. After completing it, you'll be ready to start building awesome dApps, and we're excited to see what incredible solutions you dream up. So let's get started. In this session, we will work with an application on the Casper Testnet, the counter contract. This is a simple contract that maintains a counter variable. The goal is to introduce you to the process of deploying and using a contract on the blockchain. Once you're familiar with this process, the next step will be to write your own smart contracts. Now, in order to successfully complete this exercise, we need to make sure that you have properly set up your local development environment to be able to build Rust smart contracts to WASM binaries. So if you haven't done that, please do that now. Also, you'll need the Casper Client command line tool. This tool will make it so that you can easily interact with the chain throughout this exercise. The command to install it is simply cargo install Casper Client. And we can look at my editor really quickly to see that it's installed on mine. And as you can see, I'm on the updated version, so nothing was installed for me. But of course, for yours, it will install a new client. You'll also need to set up an account on the testnet with enough tokens to perform a deploy. You'll need to make note of two critical pieces of information. One will be the account's secret key location, and two will be the account hash. We will use the secret key and account hash in the subsequent commands. The secret key will be used to sign deploys. When you're in production, you'll obviously want to create your own account and use keys that you generate instead of this one. The account hash will be used when we want to query the current state of the network. It has many other uses, but that's all we need from it today. So first, you'll fund your account. On the testnet, we have a faucet account, which supplies test accounts with tokens. You need to use the faucet to request tokens for the testnet. As a final prerequisite, you need to acquire the IP address of a peer on the testnet. Clients can interact with a node on the blockchain via a request sent to that node's JSON RPC endpoint, which is of the form HTTP some IP address :7777 by default. Both the official testnet and mainnet provide block explorers to provide a list of IP addresses of nodes on their respective networks. Next, we'll walk through the cloning of the contracts and deploying it to chain. But before we do that, let me just show you really quickly what the testnet looks like. So here I'm showing you in my browser, I've navigated to testnet.cspr.live, and this is the testnet that we will be using to deploy our transactions to. So the first thing you want to notice is that at the top, there is the tools. And if I go to connected peers, these are the list of validators that I am able to select from. So I could choose any one of these, but making sure that when I make my requests, as you'll see in a moment, instead of this endpoint, we will actually use port 7777 to indicate that we're making JSON RPC requests. The other thing will be that you will need to request tokens from the faucet account. So if you go to the faucet, you'll need to first sign in. So in order to do that, I have to go to sign in. And you can use Casper Signer or any of the other wallets that are available currently. As you can see, there's Signer, Ledger, and Taurus. So I'll just sign in with Casper Signer. And it's going to ask if I want to connect to the testnet. So I will connect. And then now you'll see that it's got, and this is just a test account, so don't worry, but now you'll see that if I go to my actual account, that I have a total balance of 949 CSPR. So when you first set up your account, you will have 0 Casper, and you will go to the faucet and put in a request for tokens. But since I already have tokens in my account, there's no reason to do that. All right, so once you've got this all set up, that's the account hash that I was just talking about. So you'll need to make note of that, and also your secret key. Okay, let's continue on. Okay, this module has a lot of moving parts, and it's quite easy to get lost in the details. So before we do anything, what I would like to do first is to introduce you to the necessary commands for the Casper client that will allow us to accomplish the goal. What we're going to do is, 1, clone the counter contract and look at the source code briefly. 2, check out what the network looks like before anything is deployed to it. 3, then we will deploy the contract and see what happens on the network. And then 4, we will increment the counter in 2 different ways so that you can get a sense of different ways of interacting with the chain. So now that we have a sense of the big picture, let's first dive into the commands that we'll be using so we can demystify them a bit. So first up is the command get state root hash. And this is of course part of the Casper client, and that's why we needed to install it. The state root hash is worthy of a momentary discussion. You can think of it like a snapshot of a moment in time, much like Git's commit IDs for version control, if you're familiar with that. It captures the current state of the blockchain and lets us query to see what things look like on the chain at that moment, particularly in relation to our account. Make sure that you get the newest state root hash after writing anything onto the chain, or you'll wonder what went wrong when you see nothing happening because you're using a stale hash. Also, for the node address argument, you would have to replace the URL with the address of one of the nodes on the chain, just like I showed you a moment ago. Once we have the account and state root hashes, we can query the network state to see what's happening on chain in relation to our account. This command is quite intuitive, even though it may look a little overwhelming at first. The node address, state root hash, and key we discussed a moment ago, but the last query, Q, is something we have not yet looked at. When we do the walkthrough, I'll show you how to query the network with and without this query argument. But to explain its purpose briefly, it essentially lets us dive further into the details of interest. The session name will pertain to the smart contract that we will deploy to the chain. The session named key will refer to a named key defined in that contract. Once we deploy the contract, our session name will be counter, and our session named key will be the count that we'll be maintaining. So let's continue to see how we would actually do the deployment. The put deploy command is designed to do exactly what the name suggests. It attempts to deploy something onto the blockchain. With this usage, we're saying that we want to deploy the contract counter-define.wasm specified by the session path argument. The node address is a server, and the chain name specifies the blockchain network we wish to deploy to, which in this case is Casper Test, the official Casper Testnet. The secret key is the account that will sign for the transaction and pay the transaction fee. Obviously, that's our account here. The payment amount has to be a set minimum. This type of local testing is an excellent way to estimate how much gas fees your contracts will incur. In a moment, I'll show you how when I specify a low amount, the transaction gets rejected due to insufficient gas fees. Notice that this is still a put deploy command, but now we have replaced the session path argument for session name and session entry point. The session name is the name of a smart contract identified by the name key, and the session entry point is a function defined as part of the smart contract. This is how we can invoke a function on the chain. When we take a look at the counter-defined contract in just a moment, you will see that there's a function named counter-inc defined in it. Note that calling an entry point with the put deploy command requires that you already have the contract deployed to the network, or else the session and entry point will not exist and the deploy would fail. So now we know how to deploy a contract and also how to invoke an entry point that is part of a deployed contract. But how do we know if the execution was successful? When the put deploy command finishes executing, it returns a deploy hash. We can use that hash as an argument to get deployed to see if the transaction was successful. This is also much more straightforward than querying the global network state using the get state root hash and then having to search for the specific named key. All right, with those commands in our arsenal, now we can walk through this flowchart and see the blockchain in action. So let's dive right in. First up, you will need to clone the contract code from the repo. In actuality, the example contains two contracts. The first contract, counter-define, creates the named key counter that allows us to reference the contract once it's deployed. It also defines the key count that will be the variable holding the count as we increment it. The two functions, or entry points, it defines are counter-get, which retrieves the count value, and counter-inc, which increments the value by 1 whenever called. The counter-call contract assumes counter-define was already deployed because it just looks for the named key, gets the count, increments it by 1, and then verifies that it was actually incremented by 1. Let's take a quick look at the source code together. All right, so I've already gone ahead and cloned the repository, but if you just take a look at the two folders that we have here, it's counter-define and counter-call. So counter-define is the one contract that actually defines what our counter is going to be on chain. So if I open up the source code, the important things that we want to take a look at is that here we've got the key that we're going to be referencing, and then we've got counter-inc, counter-get, and the counter key. These are going to be our named keys that are going to be on the chain. And the associated function is counter-inc, which retrieves the value and then increments it by 1. And then counter-get simply retrieves that value. And then finally, we have the main call function, which is the entry point into this contract. So when it gets deployed, the virtual machine will look for this. So you can see here, we've got one entry point being added for counter-inc, another one for counter-get, and then everything here gets put onto the runtime. So this becomes available on the blockchain. And once it's written onto the chain, it's permanently there. And that's the great promise of blockchain, obviously. So now if we look at counter call, you'll see it's a much simpler contract where it's not really defining much other than just I am querying the smart contract based on that named key. And then I'm getting the current value with this call contract, and I'm getting counter get. And then I'm incrementing its value using counter inc. I get the value again, and I just make sure that the value is exactly incremented by 1. And that's all that counter call does. Now we want to use the Casper client query state command to check the status of the network. But remember that first we need an account hash. We also need to get the state root hash so that we can get the current snapshot moment. Once we have this information, we can check out what the network looks like. All right, let me go through these steps on my machine so you can see the expected output. What I like to do when I'm just exploring is to open up a notes document to store the variables as I query them. But I recommend as you start building out your solutions, you actually create scripts to automate these actions on your system and probably store the returned values as some variables in your larger ecosystem. So let me query the network really quick. So I'm going to use the Casper client account address command in order to get my account hash. And so I'll just type it in here. And you can see that I've obviously stored my keys locally here in some directory. Where you store your keys will be completely independent. But when I do this query, you'll see I will receive this account hash. And I will just copy that and put it off to the side and store it because I will need to make queries with this repeatedly. So I recommend you do the same. So that's my account hash. Now I want to get the state root hash, and I can get that by grabbing an IP address of one of the validators and then calling the get state root hash command. So here I've got Casper client get state root hash with a node address, and recall that we have to use port 7777 for the JSON RPC. And this is going to return for me this state root hash, which I also will make note of. Now the next step is that I have to call Casper client query state. So what I need to do is pass these as arguments, and I'll just keep using the same node address. You're not required to use a single node, although for this tutorial, it's much more straightforward if you do. So I will call Casper client query state, and then I will pass my node address. In fact, let me just copy this so I don't have to type it all again. My state root hash, which I just retrieved a moment ago above, right here. And then lastly, my key, which is that account hash that I just requested from the account. And so if I query state now, you'll see on my account, actually, I already have a counter. When you do a query state for yours, you should see nothing here. Obviously, I've used this account before, and so my counter is already on there. But when you run this query locally, you will see that this named keys will be an empty field. Okay, so for you, the network had nothing on it as would be expected. Obviously, for me, I already had something, but that's just because I'd used the account before. But what we want to do now is we want to try to deploy the counter-defined contract to the chain. But before we do that, we need to compile it so that we have the wasm file to deploy. The makefile included in the repo makes that trivial. With these two commands, we can both build in release mode and test the contract before we deploy it. It'll take a minute, so I'll skip the compilation portion in the video, but it might be a good time for you to step away for a little stretch when your code is actually compiling. All right, with the test results saying OK, 3 passed, we know that it finished compiling successfully. So now we can continue on. So with the compiled contract, we can call the Casper client put deploy command. Obviously, the paths that you're seeing here are all relative to my setup, so yours will differ. So please don't just copy and paste. But before doing it properly, let me show you what happens when I don't specify enough modes for payment and then check the deployment. Then I will put the correct amount and we should see that it deployed successfully. So let's give that a shot. Okay. So Here you can see that I'm specifying the node address that I was using before. The chain name is Casper Test, my key, and then the payment amount is only 1,000 motes. Now this is most certainly not enough because that's a fraction of a CSPR. So this is almost nothing. And then I'm saying this is the contract that I wish to deploy. So now I can do a Casper client put deploy, and I have this deploy hash that it returned for me. And I can use this to see if the deploy was successful. Either I can do it in command line or I can use the block explorer on the testnet directly. So let's look at the block explorer. So if I refresh my account, you can actually see right there is already the deploy. A minute ago was a contract call for no Casper. And you can see that I had an out of gas error. But if I copy and paste that deploy directly, I can also query it this way if I want to see more data. So I can actually deep dive into everything. But since obviously we don't want to have out of gas errors, what I will do is deploy it now correctly with the right amount of gas. Okay, now since I've deployed this contract numerous times, I'm very familiar with it, and I know that it costs roughly about 15 to 20 CSPR to deploy it. So just to be safe, I'm saying payment amount of 25. So now I'll do the deploy. And there's my deploy hash, which I can use to check. So now instead of actually looking at the block explorer, let's do Casper client get deploy. And I will put this deploy hash right here. And if you see execution results like this, that's an indicator that it actually hasn't finished gossiping through the network yet. So you just have to be patient until the block is finalized, and then when it is, you can see the end result. Usually it takes no more than a minute or two. Okay, and there it is. Now I can see that now the deploy results contains a lot more information. The important thing is that we have execution results right here and the block hash, and the result is success. And it cost me roughly, as I was saying, about 15 CSPR to do the deploy. Okay, well, the deploy was successful, but is the name key visible on the chain now? We can call Casper client query state to check it out. Remember, every time you call Casper client query state, you have to get the new state root hash since we just wrote a deploy to the chain. When you're running through this example, you should have nothing until you call this updated state root hash and query state. So let me do that in my editor really quick. So first I want to get the state root hash. And I have it right there, so I don't need to type it again. All right, so here's my latest state root hash, and I will copy that. And then what I want to do is query my account. So remember that's Casper client query state, and then I supply the node address, the updated state root hash. Okay, so let me paste it, and then I'll explain what I'm doing here. So as I was just saying, Casper client query state, the node address that I've been using, like I said, it doesn't have to be this node address. You can use any of the connected peers. The updated state root hash, which is right here, I just pasted it in here, and then my account hash. And so now this should spit out for us a bunch of information, and hopefully we will have this named key. So as I was saying, on your end, when you run this prior to doing the deploy, named keys should be empty. And then afterwards, you have obviously this counter, and that's explicit because we actually deployed the counter to the chain. As I mentioned before, we can actually dive down even further into the data structures in the chain. So let's quickly just look at these three commands so you can see what I mean. So I just did the simple account key query, which is what we just saw. And that retrieved for me all this relevant information. I want to repeat that command, and I just wish to add a query argument. Let me go to the end of this. So the same command, but now I'm going to add a -q. And first, let's just dive into the counter. So now I'm asking for this named key as a query argument. And I know it's counter because I know it's a named key right there. And so let's see what query state is going to return for me. So you can see it didn't return all my account level information. It returned for me specifically all the things related to this counter name key. Specifically, what we're interested in is this named key called count within this named key called counter. So we can dive a little bit further in. So same command as before. And let me jump to the end. And instead of doing counter, I will do counter/count because I know this count exists within this contract. And here's the information that is really of interest to us, is that now we have a stored value and it's of type CL value, and its parsed value is a 0. As expected, we deployed a counter to the chain and initialized that counter to 0. So here's our value. And this is the value that you will see that we will be incrementing. And lastly, I can call Casper client query state to actually get the direct information related to the deploy. The important thing to note is that unlike before where we're passing the key as a count hash, now we have to preface it with deploy and then the deploy hash we had a moment ago. So we can start with the Casper client query state, but instead of this account hash, we'll replace that with the deploy. And so you'll see that the deploy was successful, the gas was this much, and that's another way of looking at the contracts. Now, of course, as I showed you a moment ago, you can also see this information with the block explorer. So depending on your workflow, one may be better than the other. All right, so we have a counter on the chain and we verified everything is good. Now we want to increment it. We can do that by calling the entry point counter inc, which was the function we had defined in the counter defined contract. So let me do that really quick and wish me a little bit of luck. So I'm just pasting all this instead of having to manually type it out. And then you can see the one distinction here is that I set the payment amount to a lot less than before. Remember, we were doing about 25 CSPR. Well, I know personally from experience that calling a entry point that is already on chain is a lot less in terms of payment amount. So I just reduced it significantly here. So now let's call this and we get a deploy hash. I will copy it over and hang on to this hash because I will need it in a moment. So I think I incremented the counter correctly on the chain, but how exactly can I be sure? So one thing I can do is I can query the network again, but notice I have to once again get a new state root hash. This is super duper important. Every single time you've modified the state of the network in pertaining to your account, you need to get a new state root hash so that the updates are present. Also notice that I'm just looking at the count with the query argument since I'm not concerned with the rest of my account right now. First, I will get this new state root hash. I'm going to copy this over. I'm simply copying just to save us time, but you see the state root hash is this updated one. You can look at the last for it to verify. And then we can get to see if the counter has been updated. All right, as you can see, now the number has incremented from 0 to 1. So we know that the entry point successfully executed. We could have also verified that the actual deploy went through either through the block explorer or again by getting that deploy as I showed you a moment ago. So multiple ways of verifying transactions, but since I know the counter has been incremented, I know we're all good. All right, we are almost done. So we did have a second contract named counter call. So let's see if we can increment the count using that this time. Keep in mind, as I mentioned earlier, this is another put deploy call, just like when we called counter inc a moment ago. And it goes without saying that these paths are obviously going to be different for you depending on where you compile the contract. But for me, it's going to be what you're going to see in a second. So let's give this a shot and see if we can increment the counter this way. Once again, I'm just going to copy and paste it. I'll just take a moment to show you. We're looking at the same node address, same chain. My secret keys, obviously these will be in different locations for you. Payment amount, and then here is where I compiled counter call. If you followed the basics of the tutorial, they should be in the same location for you. So now let's call this. And there is our deploy hash, which I will hang on to. So now just before we wrap up this guide, let's make sure that the second contract did in fact update the counter from the first contract. So just as before, I need to get a new state root hash, and then I can query the network. So Casper client, get state root hash. Here's my updated state root hash. Let me copy it over And now if I call query state, making sure that I'm using this updated state root hash, and then I call and query into the counter. Keep in mind, if you call get state root hash and you receive a new state root hash that is identical to your previous one, that means whatever you deployed likely did not get gossiped yet into the network and is not on chain yet. So just wait a moment and then try it again. But I know this has changed, so I know that my internal state of my account has been updated. So then if I query the counter, I can see how exciting. Now I have shown two different ways where I was able to increment the counter. One was through an entry point that was in my smart contract, and the second way was through this counter call contract that is explicitly calling my existing contract on chain from a separate smart contract. All right, well, that wraps up this module and unfortunately this brief course journey with you. I hope that you've gotten far more familiar with development on the Casper network, and I'm excited to enter this new decentralized world with you. See you in the next course, and until then, join us in any one of these platforms and let's build the future together. Thank you for watching, and goodbye for now.